Hello guys, Merry Christmas and Happy New Year to also. Alright, a quick one. Still on the free energy project that I've been working on while I'm trying to avoid this particular one not being set aside and undocumented like the previous ones. So I felt let me put this one into video and document it for others to learn and take cautions. So yeah, we have our universal motto. This motor can spin on DC and AC, but presently I'm using it on an AC source. While we have our alternator, this happens to be a car alternator, about 19 amps. And here we have our MPPT charge controller, outback product from the Flex Max 180. So that's the Flex Max 180. That's about 80 amps charge controller. And our battery 12-volt system. And we have a buck converter. The buck converter is meant to power the rotor of the alternator. It's been powered through the brush. So we're not using the factory fitted design. From the fitted design, it came with a regulator. From the factory fitted design, there was a regulator here that regulated the voltage that goes into the brush, into the commutator. But my design is not working that way, so I have to bypass it. One of the aim is to get an higher voltage, and with the regulator being there, it won't be possible to get that. So this is the rectifier that came with the factory fitted rectifier that came with it. And on the rectifiers and the what's it called? I think the regulator is attached to this also. So on the rectifiers, you can see there's about 1, 2, 3, 4, 5, 6, about 6 diodes in it. And I'm not too sure how the diodes are being set up, but it's definitely not in a full bridge design. So that's the rectifier that came with it. So what I'm doing with my design is I'm aiming at having a higher voltage. I was putting the voltage in parity than the current. I want more voltage. So we have our 3 phases coils. You can see the coil from these are the coils output. So it meant to be in 3 phase AC. The outputs are meant to be in AC, while the rectifiers changes to DC output. So what I did was I connected all the coils in series, so I can have only a 2 output, and that simply means I'm having a higher voltage than the current. So from the output of the coils, we have our 2 wires, 2 outputs that goes into our diode, our rectifiers. From the rectifier input, we have the 2 wires here. That's from the AC input. While we have the DC input, the DC output rather, from the rectifier. And that's our, let me see, negative and positive. This is our positive line, our negative lines. And from the output of the diode or the rectifier, put a capacitor to filter the output to give us a clear DC output, and a capacitor of about, let me see, 1500 UF to 250 volts, because I think I'm having about close to 75 volt output from this design. So and my rectifier happens to be a 60 amps and 1200 volt rectifier. So the rectifier is capable of handling up to 1200 volts, which is perfect for this design. So so far that's it. And okay, so the buck converter, you can see it. The essence of the essence of it is to supply an adjustable voltage, preferably around 5 volts or a little below, to the commutator to energize the electromagnets inside. So, being a buck converter, I can easily adjust my voltage and current from here, while the input of the buck converter is taking its power from the battery, our 12 volt source. And here's our charge controller, as I said, and that's the input from the source, and here's the battery input. So that's all. And why the two motors are being intertwined to one another. So our motor happens to be, I don't know if you can see the writings from here. So on a low spin, it's meant to be about 400 watts, meant to consume about 400 watts, and that's let me see, that's about 3.0 amps. That's in low spin, and high spin rather. One in low spin is meant to consume about 180 watts. So that's okay. So that's how it works. And both of the motors and the alternators have been linked on a belt. The tolerance of the belt seems okay. So that's it. So at first I did a design of using what's it called? A three-phase rectifier. It didn't work as I want, so I had to change it back to a two-pole input, two-phase rectifier. So that's the basic of the equipment or the tools I'm using for this job. So while we go into the testing stage of it. Okay.